So we'll go through UHDAS at sea and what happens when we, stop and start a cruise and start from scratch. I will also point out the fact that there's a website, and right at the moment, it's logging data in port, so the website is very boring. So I'll show you snapshots of two other websites. And another thing people ask for, so this is actually coming from what people wanted from what went wrong Wednesday. And I'm gonna show you how to send a. So this is something which you need to do if your ADCP is busted. So we see something wrong, send you an email, and we say, hey, could you run the following command? And you're like, I don't know how to do that. Okay, now you will know how. I'll give you a quick tour of the live UHDAS website. And in terms of best practices, there's a link. And I have one extra thing that I want to add. And if there's any time at the end, which there may or may not be, we'll take questions.
Yeah.
Fine, because my folks here, David and Drew, will tell you that I'm happy to talk about ADCP and UHDAS anytime, all the time. Okay, what is UHDAS? University of Hawaii Data Acquisition System, and it is an overused term to encompass several things. One of them is the acquisition of ADCP data, heading data, and timestamping it all, logging it, putting it on the disk. Another thing it is the name of the application that does that. And another thing it is the wrapper of all of that, plus the automated processing, which occurs at sea, and wrapping up and sending us daily emails that we look at to find out what's going wrong. So our job is we wrote it all as a group. We wrote all that software, we maintain it, we move it forward, we try to keep up with the underlying moving rug of software changes that happen in operating systems and whatnot. That's the short story. There will be more tomorrow or whatever, I think it's tomorrow for lunch. I have a full 10-minute thing. And I'm not gonna go through very much of what I just said. Okay, so let's go straight off to Kilomoana.
That was Europe.
Where I have a shortcut to get myself into the Kilomoana. And then I'll do a desktop share. And we should have the
Yeah,
Kilomoana
not many mountains here.
desktop. Any minute. It's not the network to the Kilomoana, it's this Wi-Fi, I think. Okay, so this can get kind of confusing, but this thing here.
Pretty cheap.
Okay.
Yeah, for $1.
People who are on the call, because I'm asking them to mute.
The euro
Yeah, but I'm
dollar
getting
is
the-
pretty much 1 to 1 now.
To the
It's
pictures.
very close.
I'm still stuck with pictures.
These.
I love you all. I'm sorry. No, we're waiting for the website. We're waiting for the things to move around. There we go. I think we got everybody muted. Okay. We can start and stop logging without the GUI, but it's not easy. And there are times when you actually have to do it. There are times when you actually have to use a web interface on a ship to configure an instrument, and that's when this becomes really painful. Okay, so over here on the left, we have the website, UHDAS website, which is updated. Most of these figures are updated every 5 minutes. Some are updated every 30 minutes. They have 3 different components. There's operations and science. There's operations, and there's science, and there's diagnostics. Come on. Right, I moved my mouse, I clicked on the thing, I dragged it up there. Should start a timer. One of the problems with this is that over on the right, the UHDAS GUI is continuing to update with green bars. All these little things are coming through, and this desktop is trying to refresh all of that. So a fair amount of what we're dealing with right now has absolutely nothing to do with running this at sea. All right, so I've already clicked on that thing and already dragged it over here. Should pay for the upgrade. Okay, come on. Deepest apologies. And my shared frustration. We're still waiting for the cursor to go from over here to over there. Mhm. That's not gonna, it's not gonna help.
Oh, no.
It's this Wi-Fi.
Oh, gotcha.
Those guys have perfectly good Wi-Fi. There we go. Mouse is moving. I could have simulated the start-stop part locally, except then you don't get the actual sort of live behavior on the ship. I wonder if my phone would be faster.
What if we made like a hotspot from a phone?
That's what I'm saying. I don't know whether that would be faster. Well, then that would break the Zoom, so I don't really want to have to go set up all that stuff again.
I've tried connecting with a hotspot and it kept disconnecting.
But that would not be good either. All right, welcome to the real world. We'll be done with this part soon. There it goes, there it goes. All right, so I'm gonna push this over to the front center. So this thing over on the right is the UHDAS, we refer to it as the UHDAS GUI. The University of Hawaii Data Acquisition System Graphical User Interface. And in this mode right here, monitor, it is showing us with the fact that the bars are green means that it's updating regularly. And on a regular system, you can see the numbers chunking forward. Right now, I suspect that those numbers chunking forward and the fact that it's trying to update the screen is why it's not listening to me. Sort of feeling like this costs as much to wait for as it did to take the helicopter and drop those XBTs in the ice or the single samples. It's a really expensive way to spend time. Come on.
You still have that star shield?
Huh?
I was thinking you still have the star shield.
They're the dock right now, aren't they?
They're the doc.
Yeah, so they.
They're at the pier, they're on the university
No,
Wi-Fi.
No, I didn't.
She talked about the one I bought yesterday.
Oh.
Yeah.
That's a good question.
Oh, yeah, Thomas, do you?
Oh, this is
That's
terrible.
what
This is horrible. I could probably take a demo of it faster than this. All right. Okay. Okay, that's the monitor tab. Let's go over to the control tab. And if we hit that, then we have the ability to stop recording, which would maybe make this faster. This is just gonna chew up all the time. Another issue with this is, and this is part of our real life. You can have this up in some part of your big desktop and you want to go do something else while you're waiting for this. That means your mouse moved all the way across the desktop to get off into the rest of your screen. And then when you want to do something, you have to bring it on and it has to walk all the way back over again. Not sure it really speeds things up anymore. Okay. Pretty soon I'm gonna have to find because this is not useful.
You maybe turn off the video for the Zoom. You're sharing the screen anyways. so.
But true, I could try that. Yeah, because it doesn't matter. You guys don't need to see me. All right, that's a good point. Where's my video? Probably if I stop share,
That's the computer screen share.
kill the video. And
Yeah,
then
we
go
can
back
share.
to share. Back to share. Share all. It's a good idea. Yeah. Okay, there's the control tab. Maybe that was it. So there's the control tab. So we're currently in what we call a cruise is active. That means you can see the name of it up here. In reality, that means there's a directory structure where all the data get written to, and there's a symbolic link pointing to that directory structure. That active cruise is just the fact of that link pointing. The target has already been made. If we want to stop recording at this point, we go down here and we hit stop recording. Speedier. Speedier. Oh. Okay, a little bit speedier.
Yeah.
You can quit this window without stopping the underlying data acquisition process. For advanced, don't worry about it. Do you want to stop data acquisition? Yes, that's what I want to do. Stop the data acquisition. So it goes over to the terminal tab and sends a wake up message to each of the two ADCPs, and then it flips back over to the control tab. Now, at this point, if you want it, that's what you have to do if you're going to either, if you say stop logging or secure the ADCPs, that's what you do. Don't go hit the deck unit and turn it off, because if you do this, we'll know that you did it on purpose. This is also what you do if you want to change parameters. Hey, you've got bottom tracking on in 4,000 meters of water, please turn it off. Well, then you hit stop recording and you go over here and you hit off or on or change your parameters to some other thing. So let's just do some random thing. And then you hit start recording and it goes over to the terminal tab and it sends a wake up message to each of the instruments along with the dialogue and all of the commands that have been sent, all of what its little brain says. And this is actually slow on purpose because we have little time delays built in because some of the older instruments are slow and stupid. Well, no, not stupid. They're slow and tired.
You know.
Actually, one of the oldest ones is one of the best ones, but we did have to slow down some. Huh?
I'll say that anyhow, that's my equipment. Slow.
No, the narrowband 150 is part of why we built these delays in.
Yeah.
Because we still support the narrowband 150 and we had to slow things down because of it.
I've seen that even with our newer equipment, you sometimes just have to put the place in if you're running a higher watt rate.
Yep. Okay, so then we have the green bars. The green bars are coming in. That tells us that life is good. So the two key things here when you're starting with a new instrument or something, you go into terminal, you set up your baud rate, you set up we set up the command files. You go into terminal and let's go do that right now. So we've gone through this business. Now let's end a cruise and start talking to the instrument. Let's go back over to control. Let's go back over to control. Almost at the end of all the time delay stuff. Come on, I don't even know where the cursor is. Oh, there it is. It's on Faruno right now. We're waiting for it to climb the mountain up to control. There we go. Nope. Nope. There you go. All right. Okay. Now let's end a cruise. So stop recording. And in fact, at this point, you don't even need to end the cruise if you want to go talk to the instrument. So let me show you about the terminal window. See how that just switched from not connected to is connected? Over here, not connected, just switched to is connected. Is connected means that this terminal has a two-way dialogue with the instrument. When you flip over into the monitor tab, it disconnects from this terminal and switches the logging over to C programs that are listening to the USB ports, the serial ports. And so what you normally would expect on your terminal is this is still connected. Connected means you can go to command and you can send a wake up or a break, the same as the thing at the bottom that says send break. And it sends a little pulse of voltage out to the instrument and you get a wake up message. So when you put a new instrument in and you have a baud rate, whether you're doing this with BB Talk, which is the thing that comes from RDI, or you're doing it with this, or I'll show you another way to do it, which is really just the same thing, but not embedded in the UHDAS system. You're sending a little voltage pulse out to it and it comes back at the baud rate you've specified. It gives you an ASCII message. If you see that, you get a beer. I mean, you deserve one and you can go have one. If you don't see that, you have a problem. And it could be any one of a number of kinds of problems. You need to troubleshoot more. Hopefully you just forgot to turn the deck unit on. Okay, so wake up and send break, those are both the same thing. They both send a little pulse out and you get the answer back. Let's say that you're on the ship and there's some kind of a problem and RDI says, go get your BB Talk and run the following commands. You can do those here too. You don't have to go get BB Talk, although if this isn't working for some reason, knock yourself out. BB Talk is an executable that is free from RDI and it runs on a Windows machine. So if we wanted to say PS0, for instance, Give me your basic configuration. You can find out what the frequency of the instrument is. Okay, that's 0. There are others you can do, PT 200, there's stuff, there's commands you can run that will give some information about them. If we go up here and say disconnect, that means this two-way dialogue doesn't have any effect. So it's grayed out down here. I can't do anything. So let me show you the other way to talk to it. If we go to, let's go end cruise. End the cruise. The content of the terminal, Workforce 300 and OS 38, those are all written out to screen, to files. And if you wanted to save the content of those to files, you could do that yourself. All this business about seconds that it's not letting me go back to the beginning, that's all related to underlying processes that are running. Trevor, we should talk about this because my guess is it's trying to log to media KMNAS ADCP, and that isn't there. And
It's there.
Well, it got switched from media KMNAS to medium KMNAS ADCP. Wait, that's on my list to talk to you about. So in about 60 seconds, this will time out. This is a problem that we have, but
This is an ORSync.
this is an rsync. Yeah, and we're waiting for it to time out, I think.
Yeah, it'll take 120 seconds.
Okay, it'll take 120 seconds. All right, meanwhile, let's go check. Let me bring up a terminal and let's go check the ports, because I think all this is doing is waiting for some other thing to happen. It's probably already released the port, so we can probably already go look at some of it. Come on, give me terminal. Oh, that was very stupid. That's not even what I want to do. I'm looking at the ports to see if they're, I don't want to look at those. Wait. There we go. What did I take now? Oh, what did I take now? Oh, or lock. Try that. All right, so this thing is back up. We're done with the GUI. We have ended the cruise ID equals none. Okay, so roughly that was, the summary is, if you walk into a cruise that's already working, it should be on the monitor. Best practices says it should be on the monitor tab, so you've got great big green bars to see. And then if you need to stop it, you go over to control and hit stop recording. And you can either change commands and hit start recording, or you can hit stop end cruise. So let me get rid of that. I should have checked the bottom rate. Let's see. So all of our control information is stored in a TOML file. And what I'm going to look for here is okay, let's just talk to the OS 38. So the device is called TTY USB 3, and the wake up baud rate, the communication baud rate is 9600. So if I go up to this little thing here that looks like a serial port and click that, I can pick. I can pick the port, which I can pick the device, which is TTY USB 3. Here, TTY USB 3. It says not connected, and then I can set the baud rate, which should already be 9600. Then I have to go say connect to port. Now it says is connected. And now I can send that wake up command, send a break. And there's the message, happy. And then you can type in down here, PT 200 or whatever. So that's running commands that are diagnostic commands that REI knows about how to read. So if something happens to your ADCP and we get concerned, we'll email you, we'll send you pictures. We'll have a ticketing system that keeps track of this. We'll say, hey, there's a problem. Do you want us to open a ticket with RDI? And usually the answer is yes. I have not yet ever had anybody say no. And then the answer is yes, and then we're off to those guys and we say, hey, we got a problem. And send them basically the same information and say, what should they do about that on the ship, and let RDI guide the people on the ship about what to do. And then if you want to save your log, you can go up under file, I think, save previous, and you can stick it someplace. I'm not gonna bother, but you can save the file. All right, let's get rid of that. And
Can I expand on that real quick?
what's that?
Can I expand on it real quick? If you have an issue and you need help, you might also want to email us at rdifs@teledon.com.
That's what the ticketing needs, is that we will email you at RDI.
Yeah, we get a lot of your tickets though, and sometimes it's not really related to anything, so it's easy to get missed. So if we miss you, just go ahead and email us back, let us know.
Okay. What is the email?
rdifs@teledon.com.
Yeah, I admit it, once it gets a little awkward when you start having people adding, anyway, the ticketing system can have problems talking to other ticketing systems or other people.
Yeah.
Okay, let me go back and, okay, so if you're gonna start a cruise, then you go up here and you click on this little icon that looks like the UHDAS logo. So you click on the icon, it's the UHDAS logo. It's little currents that are going like this. And you click start cruise. And so we'll give it a name, KM 2418 post 2. There is a best practice thing about naming your cruises. It's not utterly critical if it's a test cruise, but if you're naming a cruise, whatever you do, it should sort in alphabetical order the same way it sorts in time order. And there are multiple ways people do that. Okay, we have a cruise. And then you would set your parameters over here, start bottom tracking or whatever, and say start recording. All right, so I'm gonna start the recording and then I'm gonna, so it's having its dialogue with the instrument. Okay, over here on the left, we have the website. In about 5 minutes, the top panel will populate, and that'll be a little profile, 5-minute average profile. For the Workforce 300, it's actually a 2-minute profile, but whatever. So the profiles populate after about 5 minutes, and then after about 15 minutes, there's enough data to see something in the second and third panels. And then even though the figures get updated every 10 or 15 minutes, down below, it takes a lot more data before the contour as a function of latitude or longitude actually works. So I'm gonna get out of this and go elsewhere. I will kill that window and we'll go back over here. Okay, so UHDAS at Sea live demo. What the buttons are for, starting UHDAS, doing stuff in the middle of a cruise, starting from scratch, sending commands to the instrument. So let me now go over here to the live website and let's go look at the blank set.
Ours is live right now.
It's not live. This is something that in both of these cases, it's something I grabbed when it was reasonable. We don't ever look at the website live.
Okay.
Not unless we share the desktop, and that's only under rare circumstances, so. So this is something that I rsynced a while back. I made a copy of it for exactly this purpose. 8 for that. Okay, so let's just pretend that we're at sea. Okay, we'll pretend we're at sea, and so when you're at sea, there is a, usually the UHDAS console will have a copy of this website up. You can get it on your own computer and you can read stuff. You can read documentation. You can go read the entire documentation. Come on, do it. Well, all right, don't do it then. Hang on. Some of these links don't work because they're supposed to be at sea and it's not pointing to the right place. Let's go to right here. Okay, so this is the entire CODIS documentation, CODIS plus UHDAS plus, operations, all kinds of stuff. If you go to my personal, slide, if you go to my personal slide, you can click on a song that David made by going to an AI song generator. He fed them this documentation and said, give me a song in the style of Garth Brooks or something like that. It's hilarious, and I mean, it's awful, but it's amazing. It's amazing that it worked. Anyway, yeah, if you want to see, here's something funny, go click on the theme song. Okay, so here's the website, and Figures Live is the one that you would see if you were at sea. So, Langseth has an OS 75. Everything is usually absolutely hunky-dory on that ship, and so we run that in broadband mode and narrowband mode so that we've got two different resolutions. The top panels are, oh, I should have brought that documentation back up, because some clever person here said, what the heck are all those pictures? I don't know what they are. And I don't know how to explain them to anybody, but I think if you go to UHDAS operations, there is UHDAS website overview. I did do it. I finally did it. UHDAS website overview. So most of the stuff that I'm just about to say, I will abbreviate, because you can go here and you can read it. And in fact, is that actually the same website that I used for this example? Not quite the same. It looks mighty similar, but it's not exactly. Okay, so the explanation for these figures is on this part of the documentation. And so if we go back over here, this top panel is one beam worth of backscatter with no filtering done at all. So you can see the acoustic interference in it, these vertical stripes. We take that out before we edit, we take that out before we average the data. 5-minute averages, east, west, north, south, red, blue, they're labeled. And then the second set of, these update every 5 minutes, and the second set of panels, this thing here, let's just take a look at that. The north-south velocity is pretty much right on 0, and the east-west velocity is positive. If we look down here, it's the last profile here, and you can see that the north-south velocity is kind of close to 0, and the east-west velocity is positive. So that's how you translate between the wiggles and these colors. And then those same arrows are down here in the vector plot. Let me just bring one of those up. So we're talking about mainly east. So let's go bring one of these up. Okay, green is go. Green is go. Red is stop. They went down, they came back again. The X is where they stopped, and the velocities are mostly east. Let's go back here. Now, if we go over to the top two here, these are diagnostic plots. So any heading device we have, typically we use a reliable one, like the gyro is our reliable heading device. And then the accurate heading device might be something that has quality errors. A classic would be the POSIT V gets a bird on the antenna and the heading accuracy error gets really high and the headings get bad. And so we take the heading and correct that to the accurate heading. And that's valid if these are actual gyros. Anyway, so this is just a diagnostic plot to compare them. Okay, we have the bridge plot. This is one of the fundamental early operational plots. So it has the direction of the current. It's labeled in ship terms up at the top. We've got knots and direction. And we've got the ship heading in compass degrees. And down below, it says what the range is, 31 to 39 meters. And so you can see, here we are again with the velocities basically mostly going east. And in this case, the ship is going northeast. So if they were trying to set something up to put something over the side, if they're gonna stop here, they're probably not gonna point, oh, they probably are gonna point that direction if they can. Because that would keep whatever they put off the side and the current pull it away from the ship. So typically ships use the wind as a huge, thing to pay attention to when they're parking to do over the side operations. And they use the swell as another, depending on what they're gonna do, they use the swell. But also depending on what they're gonna do, they may use the currents. And people who are doing ROV operations are very interested in what the currents are. So if this plot makes sense, let's go down and look at vector profile plot. Okay, this is the same thing, but for all the depths. So here's the same bridge plot that we saw before. There's the ship and there's the velocity going to the east, and that blue arrow is the same as this blue arrow. And it says 31 to 39 meters, which is this depth right here. So if you wanted to know what is the current doing at 75 meters, well, it's going a little bit more south, still east, but a little bit more south. What is it doing at 100 meters? Well, what's it doing at 300 meters? It's still pretty strong to the east, but a little bit north. This is all going east, so it's not really a great example, but that's what this plot is. Every single one of those vectors is a top-down bridge view, and the origin is the depth that's listed along the left-hand side.
Where is that plot?
It's under, oh, let's go back over here. At the bottom, vector profile.
Huh?
100% good. Okay, we've also got last few vectors. And so this is a couple of different depths. In this case, it looks like we have two depths. These depths are pre-chosen. We got no control over any of this stuff. But we try to provide enough different ways to look at things that it helps. But you can see that between 31 and 71 meters, the water's going slightly southeast. And between 250 and 300 meters, it's going slightly northeast, mostly east. The dot is where we are. We just came from the southwest up to where the dot is. So the dot will go like this, and your cruise track is behind that. This one mimics one that's in UHDAS, because I went out to sea for somebody who we were putting the UHDAS system on, and I spent like, I don't know, several days trying to make this plot that I thought he wanted. He said, I don't want that. I want UHDAS's vector plot. Okay. So, because he was trying to drive in through an eddy, and he wanted pretty fine time understanding from a top-down view of where the eddy stops. So the vectors get small, you're in the middle. Vectors get big again, going the other way here, on the other side. Let's see what else is down here. So we've got those. Oh yeah, the other one, I guess I'll bring up two. The other, well, okay, there's a bunch of them. All right, but this one right here, this is the one that would let you see whether, this is one of the first ones we look at. Oh, let's look at the velocities. Here. This is one of the first ones we look at to see whether a beam went out. So if we see a plot coming back and there's a cruise track, that means we have positions, so we probably have speeds. If we see headings, that means we have headings, but if there's no velocities, something went wrong with the velocity calculation, and the most likely thing is that one of the beams died, in which case 4-beam solutions will give you gray nothing. But if you look at this plot, you can see which one is gone. And there have been multiple times when a ship can't take their ADCP out of the hull until the next dry dock. And we can go take, if it's just one beam, we can go take that beam out of the equation and we can get the velocities back. So the investigator went, oh, I don't know, 9 months or something with 3 beams. It degrades your final quality assessment tools, but it doesn't make the velocities actually any worse. I mean, it's not the first thing to make your velocities worse. There are a lot of other ways to do that. What else do we have? Okay, this is another, so this is our secret stuff here. This is the secret sauce. Okay, the beam velocities is one of them. Don't look at ocean velocity errors. That was an experiment on my part, which is pretty useless. Temperature diagnostics. I would call this a caterpillar. Okay, so this is, if you looked at this temperature, you'd say that's not a scientifically useful temperature. It's got spikes on it. Well, it's got fuzz on it. It's got a Don Johnson beard. It's not really spiky. It indicates that there is electrical noise getting into the system through the cable. So probably electrical noise getting into the system through the transducer cable, but it's at a low enough level that it's not affecting the velocities. If we have spikes that go up to 92.36 C or so, that means you got water in the electronics and it shorted something out, and that means imminent failure. Yeah,
Is the OS 75 kind of like the OS 38 where it's analog between the deck unit and the?
all the OSs are like that. Yeah, that's an excellent point. So
Yeah.
what's happening is that for the ocean surveyors, all of those lines in that big fat cable, they're all carrying analog signals. And so if they all get distorted together as they either go past a fuzzy generator or some other thing, at the other end, they may all be analyzed as consistent and fine. In which case you can end up with bad stuff. Or if this, so this is like some kind of static hitting it. The Workhorse 300 is usually an RS-422 communication line going up well, it also includes power, but going from the transducer up to the deck unit, you have 422 communication and power. And so normally you can't get that kind of problem going in through that cable. You can if it comes in through the power, but normally Workhorse 300s are extremely reliable against this, but this is an ocean surveyor diagnostic and we didn't know about it. We didn't know to look. And then Falcor Langseth went to 92.36 and it's like, oh shoot, I should write something that reads the temperatures and makes a statistics file. And then we learned how much then the bandwidth increased and we can make a plot. So now we always have a plot. So anyway, that's what this one is. And we get this every day in the email. And another one that we get every day is GGA time differences. So this one is, so this one has all of the instruments like this, in this case, CPAP and POSNV, and then we have different zoom levels. And so in this case, this is the dreaded free inertial. So this pink thing here means that just before the east or west designation of the position is a 6. And that 6 means that the CPAP is saying, I don't know where I'm going, but I know where I just was, so I'm probably here. It's dead reckoning. And I'll show a picture tomorrow about how very bad that can be. It is true that if it's a tiny little glitch, it doesn't like wander off too fast. But for this size of a glitch, at least in the positive example that I'm going to show, the latitude wandered off by 200 meters and the ship speeds went crazy. It's just, you can't use those positions. So if this happens with UHDAS, everywhere where there's a pink thing, we don't have a position. And so there will be gaps in the velocities, which also have gaps in the ship speed and in the position. So that's the diagnostic that something went wrong with your positions. So we look at these. And if you told us not to tell you about it, we're trying to not tell you about it. So an example there would be the Thompson, whose CPAP is kaput. They know it, they ordered the part, it didn't work. CPAP said, go take it home. Well, it's your deck unit. And so they took it home and they connected that deck unit up to the Rachel Carson and it worked fine. So it wasn't the deck unit. And then they took it back and it turned out then they had antenna problems and cable problems. And so it's still out for the camp. Randy asked us not to say anything anymore. I changed the name of the ticket until it's fixed. We don't bug them. They don't want to know any comments. They'll let us know when it's fixed. And let's see. There should be one more here. Where I'm not seeing the Passion plot. This must be old enough that we don't have positive V plot. Okay, let me go to the other one. So that's the one that I grabbed from the line set. Then I have one more over here. I think it's in this one. Oh, come on, sorry. No. Oh, desktop. Oh, here we go. All right, one more, Thompson. Right, so this is the same thing, this just happens to be the Thompson. It should all look very familiar, because I just went through all of this, so I'm not gonna go through it again, except to say, okay, let's get this bigger. Okay, so you can see more acoustic interference in their case. They have a Workhorse 300 and an OS 75. The OS 75 is only running in narrowband mode because they have that other frequency. Here are the velocities. You expect really good consistency between broadband and narrowband because it's the same instrument. You expect good consistency between two different instruments looking at the same thing. And for instance, this little yellow patch here, that's that tiny little yellow patch up at the top there, because this instrument doesn't go down very far compared to here. But it is, here's all this red stuff on the left-hand side. Here's all this red stuff on the left-hand side. And then we've got the velocities. Again, it's like practically nothing, and then all of that direction. We're just looking for consistency. Up here. Where did it go? Okay. Come on, come on. Okay, this would be an example of monitoring your heading inputs. So this is a case where gyro 2 went out. No, gyro 2 is there. CPAF compared to gyro 2 works. Gyro 1 compared to gyro 2 is gone. So this is one where every, I think, 30 minutes this plot comes up. But if you see a big blast of red in there, that means something bad happened. Go find out. We only get that email once a day. These do all have one little stripe every 2 hours. Nothing to do about that. And the other one that I won't bring up is the speed log because I don't have an active system here. But if you click on speed log, you get a separate little window that has a velocity past the ship on one direction and behind you. And that can be useful for towing. All right, let's go back over here and find out where I am because I should open it up for questions. Oh yes, best practices. Oh yes, I remember. This is just a recent one. Oop. Where is it? Come on. Presentations. I really am doing both by the wrong Wednesday. And let's go to best practices. Okay. Okay, so this is not best practice. This is me finding a problem and I'm going out to the ship and what do I see? I see the bridge plot. I don't see any green bars. There's no way to tell whether this is alive and functioning or whether it's an old plot without going and reading the time and comparing it to the time. So in this case, it was started up and the GUI is just a little bit too small. And if you actually go down to here and you pull it down and make it slightly bigger, then those green bars show up, the green tabs show up at the top. But it is far preferable. It's really preferable to do it this way. You want to have the green bars over at the side so you can see them. You can bring up your bridge plot and then you can also see all the other plots. And I admit, I'm greedy. I like our ADCP stuff. I want people to see it. So if all you've got is the bridge plot, it's like, oh, you're only good for telling us how fast we're going or where the currents are. I'd like science to know this exists, which is part of why I want the website to be up. So this is the my new best practice is to have the green bars visible, and then however many figures you want, you can bring them up. And the Kilowatt uses the operational plots on the bridge, and they started doing that. They bought a netbook. Remember what netbooks are? This is before tablets. They bought a netbook and Velcroed it to the console at the top of the stairs so that it could see the Wi-Fi, and that let them put the plots they wanted on the bridge.
We have a tablet.
All right. Oh, I was gonna enter anybody in here from NOAA? Well, it's not gonna hurt anybody. Okeanos Explorer has two totally different, bureaucratic entities and two totally different networks, actually 3 different networks. But the Mapping People's network was not allowed to talk to the network our stuff was on, so they couldn't get our pictures. And they were trying to drive their ROVs with our pictures. And their MacGyver solution was to point a webcam at the bridge plot.
Yeah.
So they had a monitor up over here that was connected to that network and a webcam pointing at our picture, which showed up on their display so they could use it. I thought that was genius. That was before they did some serial thing where they poked the picture out through the serial feed, because serial is secure, don't you know?
I find that if you're towing stuff or doing ROVs, the vector plots are really much better,
Okay, yeah, sure, but they've got, it's the same thing, but it's got history.
and it goes deep.
Deeper as well, yeah. Yeah, so we've got the one, we've got the multiple, and we've got the time with a couple depths. We've got 10 minutes for questions because, and I'm just gonna stop share here and go back and put my camera back on. That's all I had that I was gonna say. There's gobs. Oh, so I'm sharing the Zoom now. Yes, okay. There are gobs and gobs and gobs of things. I mean, if I give a UHDAS CODIS processing workshop, it's 3 days, so. But I'll take anybody's questions now or at any other time. Yeah,
I'm curious what the, under optimal, totally 100% working ocean surveyor systems, what is the difference in range between broadband and narrowband supposed to be?
okay, excellent question, and Chris can correct me. You want to answer that? Okay.
Probably don't want to say that.
I don't know, so we're all learning. Okay, so, Lance from UH wanted to know what's the sort of nominal expected difference in range between broadband and narrowband using the standard default. So let's take an OS 75, for example, and the default broadband setting would be 8 meters and the default narrowband setting would be 16 meters. And depending on where you are in the ocean, whether you have a window or not, let's just take the absolute best case scenario. Your OS 75 narrowband 16 meters goes to 800 meters. That's rare, but it does happen. And under those circumstances, your broadband might go to something like 650. It's supposed to be about 80%. And in other circumstances, let's not take the ship being noisy. Let's just take a different part of the ocean. No window, still different part of the ocean. You might easily, like off the 15 degrees north, just off of South America on the west, there's a low oxygen zone there. And the depth that you get to changes by 400 meters from night to day with the scattering layers migrating. And so from there, the narrowband might get 600 meters, 600 to 500, depending on the time of day. And the broadband might get 200 to 400 or something like that, 150 to 500, depending on the time of day. Broadband doesn't cut it when the scattering is low. So the answer is complicated, but nominally with good scattering, et cetera, blah, 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 80%. Yeah.
Yeah, we have a lot of students that come aboard on the Carson.
Mhm.
Could you give, and so we're trying to explain to them all the instrumentation.
Yeah, you want the one sentence thing?
Yeah, so I was wondering if you could give me or us a elevator pitch of ADCP.
Sure. An ADCP is an instrument that puts out pings, sonar at a particular frequency. It has beams that are pointing outward, and it uses the Doppler shift of those sound of those beams as the ship is moving, along with heading and position, and then editing and averaging to create ocean velocity, ground truth ocean velocity under the ship.
Okay.
Is that,
Yeah, I mean, yeah, that's great. Now, I mean, I started through a lot of stuff, but, it's great.
So
Well, I mean,
sort of like it bounces sound waves off of bubbles to figure out how fast the water's
Well, I don't want to
going.
get into too much detail. I want, because these are students, these are anywhere from
well, so
people going on a tour that don't know oceanography.
okay, they may not want the 4 beams then. You can just even say it puts sound in the water. I mean, it's a glorified speed log. A speed log has 1 beam, but that's not
Okay.
pointing down, it's pointing this way. Because if it points down, you don't measure anything, you only measure the part along the beam. So a speed log would point down at an angle, and the Doppler shift is as the thing goes past you. When it comes towards you, all the pressure waves are squished together, so the frequency is higher. And when it leaves, it stretches those pressure waves out, so the sound is lower. So it uses that with the sound being, let's take 2 beams, the sound being higher here because it goes up, and the sound being lower there because it goes down. It's farther away. And it takes those Doppler things along with heading and position to figure out what that subtracts, it orients based on heading and subtracts what actually adds the position, but anyway, accounts for position and ship speed, and it gives you ocean velocity.
Okay.
So if you do it right, if you have all the calibrations in and everything is working, you stick all this stuff into the magic pot, and out comes where the potato will go when you drop it in the water. Where the drifter will go when you drop it in the water.
It's what tells us where the potato goes when we drop it.
And I picked a potato because it's likely to sink initially,
That's really cute.
because it's not at the surface. We're not doing the very, very surface part.
We're talking the russet potato. Like,
Right, oh, sure,
Yeah, like, kind of sweet.
Yeah, okay.
It's like too late.
okay. Or a neutrally pointed sediment trap.
Or how about one of the UHF radios?
You float test one?
I float tested like boxes.
Yeah, I think you gotta have a little flotation and those will actually go all the way to the bottom. But yes, anything you put in the water, if it's drifting, it will pass through the currents that are moving, and that's what this is measuring. That's on the other hand. Yes, Matt.
I've had a couple instances where science parties want something that is not necessarily being shown. For example, we were in the Gulf Stream and our maximum we were looking at the contour plot and the maximum current was 2 knots. And it was greater than 2 knots in both directions.
Yeah, and I remember that, and you emailed me about it, and the bottom line is,
It fixed itself in about 45 minutes.
it auto scales, and you had just entered the middle of the Gulf Stream where it was bigger than the previous scale. Once it got a little more data, I said, oh my gosh, I gotta get bigger.
So-
You'll also see that the contour plots sometimes come back and the two instruments will look really different. And that's because one of them, if you look at the scale on the sides, they're not forced to go together. They might be 0.2 meters on this one, 0.4 meters on that one, so.
So is there a meaningful way for us to affect those settings underway if we
You don't, well, no, you can't, actually. I mean, that's not even a well enough alone. There are some well enough alones, but that's not one of them. That's buried deeply. So essentially. Well, no, I mean, the actual solution to that, and Mary has taken care of this, although probably nobody even knows. But I think on the Revell, there is a, completely enabled, VirtualBox virtual machine. And so if somebody puts VirtualBox on their computer and they download if they put the VirtualBox software on their computer and put that virtual machine on it and open it up, they can open up a data file from the data set, and they can explore it, and they can set all those parameters. And so, well, let me just demo that while somebody else asks another
I
question.
have a comment from Rachel Simon.
Oh, yeah, please.
She said, or maybe it's a question, she said magic in ocean current info at different depths.
Say it again.
Magic in, ocean current info at different depths.
Magic.
It was a Soto Bose comment during when we were the elevator pitch.
Oh, that's what I was supposed to say. Magic info about ocean currents at depth.
Yeah.
Got it. That's on the t-shirt. I got it. Okay, where should I go? All right,
Where's that? Balance. You were at-
call it demos, yes. Yeah. Okay, I'm gonna show you what they can do at sea and you could do this, you could have a public machine, you could put VirtualBox on it. And you could put that virtual machine on it, and inside of there, they can't do any harm to anything. And they could use this to look at those figures at sea. All they have, okay, so, data viewer, and we're gonna pull up. So I'm pulling up the CODIS database, but you can do this with the NetCDF file as well, and that's on the network. Okay, so this is what you have when you pull up data viewer. You have a topographic plot over here in the corner. You have a panel plot, which as it stands has, ocean east-west velocities, north-south velocities, backscatter, and percent good. Let's put we already have that. Let's just, yeah, okay, that's fine. Okay, so over here, let me just push this over there just a little bit. We can put ship speed on there. And, so it's obvious that there's some kind of a current that's going like this. Okay, let's look at that with more detail. Let's take 10-minute averages instead of 30-minute averages. Boom.
Can you share your screen?
Oh, I'm not sharing my screen. I'm so sorry. How am I supposed to advertise this if I'm not sharing my screen? Share the whole thing. Okay, sorry, guys. Okay, so So there is a current that's going up like this, and this was a multi-beam test that we did in 2010. You can zoom in on it. All right, now we're cooking with gas. Okay, so over here, let me take the zoom off. Okay, so over here, I can move the cursor past, along the time, and you can see that this period over here at the beginning, they're over on the east. And then they went over and they started going south and north and south and north and south and, oh, east and west and east and west. There's a big internal tide here, the blue and the orange that are overlain from each other. There's a big internal tide up against the coast there. And, it's much more obvious if you zoom out. Well, we can zoom in this one as well. Anyway, the point is that the kind of stuff that you're asking for is much better dealt with in a situation like this than the automated thing, which is supposed to be utterly reliable and not messed with by anybody.
So generally, we have no control over the website figures.
That's correct.
Have that control.
That's correct. You don't. Yeah, so this is those fantastic internal tides that Hummon measured when they were out there. But anyway, there is a completely configured, supported virtual machine. It's about 4 gigabytes because it's got the topographic database in it, and you can stick it on a machine on your ship. It's downloadable from our website. You just have to have VirtualBox running, and if you have that there on a public machine, then we can ask me. I'm glad to help. I would be delighted if more people put this on their ships. Then somebody can go explore the data with this scheme. And if they totally screw it up, well, then you erase it and reinstall it. I mean, it's just an import. It's just an import in 10 minutes. Doesn't take anything else than that.
They can do that from their laptop.
If they have VirtualBox on their laptop, they can put this on their laptop, if it's an Intel chip. So this runs on PCs. And it's in fact the only way to get our software on a Windows machine. So it runs on Windows machines, Intel Macs, and Linux, which is typically Intel. If it's M1, M2, you gotta talk to us separately. There is a way to put it on there, but it's more involved. It's not a virtual machine. So it's not a blob that you stick on and import it. It can be done. Well, not necessarily, but yeah.
I thought of a useful comment for everybody that it may or may not be applicable, but on our ship, our OS 38 is in a well that has a sealed cable pipe running up like 2 or 3 decks to a rock slop or a gland essentially that goes then to the deck unit. And we are at Kilomewana in the tropics. And we traversed to Alaska, where it's very cold. What we discovered after a couple of beams dropped out was that the condensation, that I'm convinced it was, resulted in a pool of water in the transducer well, on top of the transducer.
That's what it was.
Sloshing around in the well, which caused rapid deterioration of just corrosion. So if you're a ship that operates in warm, humid air, and you haven't thought about it, you're gonna go somewhere cold, I encourage you
Look
to
for
take
pooling
steps
water.
to perhaps flush your well or sealed system with some kind of.
Well, I think it's more general than that. So basically Lance was saying, if you're in a ship in a tropical area for a long period of time, and then you're in a cold area, you're gonna get condensation, and you need to be aware of that wherever it occurs.
Yeah.
It'll drip out of air conditioning pipes and land on your computer, it'll drip in your bed, it'll drip on your transducer. It's 2. So we have to quit.
Yes.
And I am everywhere. You can find me. Thanks for coming.
Thank you.